For centuries, we've pictured planets as loyal companions to stars, dutifully orbiting their radiant masters in perfect harmony. But what if we told you there's a secret society of celestial outcasts, cruising solo through the universe? These so-called rogue planets are the ultimate cosmic rebels, existing without the benevolent glow of a parent star and roaming the vast expanse of interstellar space. Prepare to have your mind blown as we unravel the enigma of rogue planets, exploring the shocking scale of their existence and the intriguing theories behind their mysterious origins. Get ready to blast off on a journey that will challenge everything you thought you knew about planetary systems and leave you questioning the very definition of a planet. But first, before we dive deeper into this mind-boggling topic, make sure to hit that like and subscribe button for more such amazing videos. Your support means everything to us. So let's get started. When you think of a planet, chances are you picture a world much like Earth, orbiting a sun-like star and basking in its warm glow. But the truth is, the universe doesn't always follow our expectations. Enter the rogue planets, also known as free-floating planets, interstellar nomads or unbound planets, each term offering a glimpse into the enigmatic nature of these celestial wanderers. But hold on a minute. Can a planet really exist without a star to orbit? Isn't it all about gravity and balance in our universe? Well, that's precisely what makes rogue planets so perplexing and fascinating at the same time. They challenge our conventional understanding of planetary systems, forcing us to question what it truly means to be a planet. As of today, astronomers have confirmed the existence of over 4,000 exoplanets outside our solar system, each with its unique set of characteristics and quirks. However, the discovery of rogue planets has been more elusive. The reason for this is simple. Unlike stars, rogue planets don't emit any light of their own, making them incredibly difficult to spot against the backdrop of the universe's brilliance. It's like trying to find a tiny black pebble on a dark beach at night. This poses a significant challenge for astronomers who rely on observing celestial bodies' luminosity to identify and study them. However, they have managed to catch glimpses of some of these interstellar nomads by studying the subtle changes in the brightness of distant stars. This technique, called transit photometry, involves looking for tiny dips in starlight when a rogue planet passes in front of it, momentarily blocking some of its light. While this method has allowed astronomers to confirm some rogue planets, it's a long and arduous process akin to searching for a needle in a haystack. However, the quest to uncover the secrets of these enigmatic objects hasn't deterred scientists. With the advent of powerful new telescopes and innovative detection methods, the hunt for rogue planets has intensified. One such promising approach is gravitational microlensing, which involves looking for the brief brightening of a star's light as a rogue planet passes between Earth and that star. This technique has been instrumental in identifying many of the confirmed rogue planets, providing valuable insights into their size and mass. Moreover, studies using the Hubble Space Telescope and the Spitzer Space Telescope have revealed intriguing details about the atmospheres of some rogue planets, suggesting the presence of methane and carbon dioxide in their upper layers. This discovery has raised hopes that some of these distant worlds could harbor conditions suitable for life, albeit in the most unexpected of places. The very definition of a rogue planet has sparked intense debate among astronomers. Traditionally, a planet was considered a celestial body that revolved around a star and didn't emit its own light. However, the discovery of rogue planets has pushed the boundaries of this definition. After all, if a planet can exist without a parent star, should we redefine it based on its composition, size, or formation? Perhaps the answer lies in a combination of these factors. But one thing is certain: rogue planets are not simply lost causes. They are fascinating objects that deserve our attention and further exploration. Imagine a vast, dark expanse stretching as far as the eye can see. No stars, no light, just an endless abyss. Now picture a lone planet floating amidst this darkness, a world cut off from the warmth and brilliance of a parent star. Sounds bleak, right? Well, that's the reality for many rogue planets, which are typically found drifting aimlessly in the farthest reaches of interstellar space. But here's where things get really interesting. These planets aren't exactly what you'd expect. They come in a wide range of sizes, from gas giants heavier than Jupiter to smaller rocky worlds resembling Earth. Some might have atmospheres, while others could be barren wastelands. And that's just the beginning. Astronomers have proposed several theories to explain how planets can exist without a parent star. One of the most intriguing ideas suggests that these wanderers were once part of a planetary system that was violently disrupted by a large nearby star. Picture this. A close encounter between two stars sends shockwaves through a planetary system, sending its planets flying into the vast expanse of space. These celestial nomads could have been flung out of their original orbits and now roam the galaxy as solitary travelers. Another theory proposes that stars themselves can kick their planets out of their planetary systems. As the star evolves, its orbit expands, eventually reaching out and pushing its planets away. In this scenario, the planets find themselves in a never-ending game of cosmic hide-and-seek, desperately trying to avoid being pulled back into the star's gravitational embrace. Recent astronomical observations and computer simulations have shed some light on these fascinating phenomena. For instance, in 2020, researchers used data from the Subaru telescope in Hawaii to observe a young star cluster known as the Trapeze. They found that the cluster's tight gravitational interactions were likely causing planets to be ejected from their systems. Similarly, a study published in the Astrophysical Journal in 2021 used computer simulations to model the chaotic interactions within young star clusters. The simulations revealed that planetary mass objects could easily be thrown out of their systems due to close encounters with other bodies. These findings provide crucial insights into the turbulent pasts of these celestial wanderers, hinting at a history filled with dramatic events that shaped them into the free-floating worlds we see today. Rogue planets, with their mysterious origins and unusual characteristics, have captured the imagination of scientists and space enthusiasts alike. But the real question is, could life still exist on a planet without a sun? You might think that a world without a parent star would be an inhospitable frozen wasteland. After all, life as we know it depends on liquid water, which requires a relatively narrow temperature range to exist. Without the consistent warmth provided by a nearby star, it seems highly unlikely that liquid water could persist on the surface of a rogue planet. However, scientists have not ruled out the possibility completely. Some researchers believe that internal geothermal heat could be enough to keep liquid water and even support life on a rogue planet. This intriguing idea is based on the fact that certain types of planets could retain heat generated during their formation for billions of years. Furthermore, recent studies suggest that rogue planets may have surprisingly diverse atmospheres, which could play a crucial role in regulating their temperatures. Some free-floating worlds might possess dense atmospheres that trap heat effectively, creating a greenhouse effect similar to Earth's. Others could have thick clouds that reflect sunlight, keeping their surfaces warmer than expected. It's like imagining a cozy cabin deep in a dark forest. Although cut off from the warmth of the sun, the cabin's insulation and a crackling fire inside maintain a comfortable temperature. Could something similar be happening on a rogue planet? The concept of Goldilocks zones on rogue planets is an area of active research in astrobiology. These zones refer to the range of distances from the center of a planet where conditions could be just right for liquid water to exist. By studying the atmospheres and internal heat of rogue planets, scientists hope to determine whether these worlds could support life despite their lack of a parent star. The future of rogue planet research is filled with exciting possibilities. As technology continues to advance, we can expect to learn more about the prevalence and characteristics of these enigmatic objects in our galaxy and beyond. One promising development is the construction of powerful new telescopes, such as the James Webb Space Telescope and the Extremely Large Telescope, which will allow astronomers to study the atmospheres of rogue planets in greater detail. By analyzing the light that passes through these planets' atmospheres, scientists can identify the chemical elements present and study their potential for hosting life. Furthermore, missions specifically designed to hunt for rogue planets are gaining momentum. For example, the Nancy Grace Roman Space Telescope, scheduled for launch in the mid-2020s, will be equipped with a wide-field instrument that can capture a large portion of the sky in a single image. This capability will enable the telescope to survey vast areas of space, increasing our chances of spotting rogue planets and characterizing their properties. Additionally, the European Space Agency's Plato mission, planned for the late 2020s, will conduct a transit survey of nearby stars, focusing on smaller rocky worlds that could have been ejected from their systems. The study of rogue planets holds immense potential for revolutionizing our understanding of planetary formation, galactic evolution, and the distribution of life in the universe. As we continue to probe the mysteries of these celestial nomads, we may just uncover secrets that were never meant to be found, forever changing our perspective on the cosmos and our place within it. And with that, we're at the end of our journey into the world of rogue planets. If you enjoyed this video, don't forget to hit that like and subscribe button down below for more updates on all things space. Thank you for joining us, and until next time, keep looking up.